Students, we've got a beautiful question. Given that y raised to the power of 1 over m positive y raised to the power of negative 1 over m is equal to 2 times x, we are expected to prove x squared negative 1 times y3 positive 3 times x y2 positive 1 negative m squared times y1 is equal to 0. This is a very beautiful result that we have to achieve, and all that we have been given is y raised to the power of 1 over m positive y raised to the power of negative 1 over m is equal to 2x. So foremost, what we will do is we will start off by consider y raised to the power of 1 over m positive y raised to the power of negative 1 over m is equal to 2x. Next, we would be differentiating with respect to x. We get, so differentiation of y raised to the power of 1 over m is going to be 1 over m times y raised to the power of 1 over m negative 1 times differentiation of y, that's going to be y1 followed by a positive sign. Differentiating this would give me negative 1 over m times y raised to the power of negative 1 over m negative 1 times differentiation of y would give me y1 is equal to 2. Now what I wish to do is I would foremost like to take y1 out. So this is going to be 1 over m times y raised to the power of 1 over m negative 1 positive followed by negative 1 over m times y raised to the power of negative 1 over m negative 1 times y1 is equal to 2. Next, what I wish to do, I would like to move this y1 to the right hand side. So that would give me 1 over m times y raised to the power of 1 over m negative 1. Positive times negative is negative 1 over m times y raised to the power of negative 1 over m negative 1 is equal to 2 times y1. That's fair enough. Now next, what I'm going to do is I'm going to take this 1 over m outside. So if I were to do that, I would get y raised to the power of 1 over m negative 1 negative y raised to the power of negative 1 over m negative 1 times 1 over m is equal to 2 times, or I should say 2 over y1. So now what I would do is I would push this m to the right hand side. So if I were to do that, this is going to be y raised to the power of 1 over m negative 1 negative y raised to the power of negative 1 over m negative 1 is equal to 2 times m over y1. Now next, I would like to rewrite this as y raised to the power of 1 over m times y raised to the power of negative 1 followed by a negative sign, y raised to the power of negative 1 over m times y raised to the power of negative 1 is equal to 2 times m over y1. Now what I wish to do is I would like to push this y raised to the power of negative 1 down. So this would give me y raised to the power of m divided by y negative y raised to the power of negative 1 over m divided by y is equal to 2 times m over y1. Now I would like to use this part of the space, so I would like to take 1 over y out. That would give me y raised to the power of 1 over m negative y raised to the power of negative 1 over m is equal to 2 times m over y1. Now I can push this y to the other side, so that would give me y raised to the power of 1 over m negative y raised to the power of negative 1 over m is equal to 2 times m times y divided by y1. So this is 2, and I'm going to take this to be as my original system 1. So fair enough. Now you would be tempted to obtain the second differential y2, because in this case we just differentiated one time, but we need to get up until y3. So we need differentiating the quantity the second time, and then that has to be followed by the differentiation of the entire quantity the third time. But we cannot, or I would say, if we were to attempt differentiating this the second time, then we would be landing up ourselves with greater problem than we originally started with. So for that we will have to make a few alterations. So what are those alterations? So I'm going to take here, you see this y raised to the power of 1 over m. I'm going to state let alpha be equal to y raised to the power of 1 over m and beta be equal to y raised to the power of negative 1 over m. So this would mean alpha times beta is equal to y raised to the power of 1 over m times y raised to the power of negative 1 over m, which is equal to 1. So I got a value alpha beta is equal to 1. And then let me just go one step further. Also, alpha added with beta is equal to what? Alpha added with beta will be equal to 2x, right? Because alpha is this and beta is this, so we got this as 2x. Now the question comes, if alpha plus beta is equal to 2x, what is alpha minus beta to be equal to? So this would mean alpha minus beta. So what is alpha minus beta? This is alpha, this is beta. So this would mean alpha minus beta is equal to 2 times m times y divided by y1. So I got alpha plus beta and alpha minus beta. Now the question is, how are we going to connect these two quantities? The problem is solved if we can connect these two, and there comes to our help algebra. Now from algebra I can state that alpha minus beta raised to the power of 2 is equal to alpha plus beta raised to the power of 2 minus 4 times alpha beta. This is an algebraic identity which I'm using here. So simplifying, in other words substituting, so this is going to be 2 times m times y divided by y1 raised to the power of 2 is equal to 2 times x raised to the power of 2 negative 4 times alpha beta is 1. So this is going to be giving me 4 times x squared negative 4, that's fair enough. And then this is going to be giving me 4 times m squared y squared divided by y1 squared. Now we see a 4 here, a 4 here, a 4 here, so they can be cancelled. So this would now give me m squared y squared divided by y1 squared is equal to x squared negative 1. Now what I wish to do is, let me use this space here. I can rewrite this as m squared y squared is equal to y1 squared times x squared negative 1. So fair enough. So that's a nice way to get to the point. Now from here I can differentiate this the second time. So differentiating this with respect to x, we get, so what are the differentiation? So let me use this space here, this is a little bit larger in size. So m squared y squared, so m squared is a constant, I differentiate y squared, is going to be 2 times y times differentiation of y, that's going to be y1, is equal to, I should differentiate this, so it's UV form, so y1 squared of differential of x squared, that's going to be 2 times x, positive x squared negative 1 times differentiation of this is going to be 2 times y1, differentiation of y1 would give me y2. So this is what I've got. If you want, you can rewrite this. So I'm going to rewrite this over here. So this would mean I get 2 times m squared times y1 is equal to 2 times x times y1 squared positive x squared negative 1 times 2 times y1 times y2. Okay, so now I can clearly get rid of the 2. I have a 2 here, I got a 2 here, I got a 2 here, and I can get rid of this y1, a y1 and a y1. So now it's coming out beautifully. So this is going to be m squared. So let me start from here. M squared and y, this y1 is already gone, so this is equal to x, I got a y1 there, and then x squared negative 1, and I have a y2 there. So now I will have to differentiate this again. So differentiating with respect to x, we get, so what do we get? This is m squared times differential of y is y1 is equal to UV formula, x times differential of y1 is y2 plus y1 times differential of x is 1, positive UV formula, x squared negative 1 times differentiation of y2 is going to be y3, positive y2 times differentiation of x squared is going to be 2 times x. So I need to rewrite this. I'm going to rewrite this starting with this term. So let me write that. So x squared negative 1 times y3, that's fine, and then I have a 2 times x y2. So let me just place that 2 times x y2. Is there anything I can do? Yes, there is an x y2 there. So I can add x y2 with 2 times x y2. That would give me 3 times x y2. Fair enough. And what else I can do? So there is a y1 here, so let me have that y1 and let me push this to the other end. So it's going to be negative m squared y1, right? So of course let me give an implied sign here and equate it to 0 on this end. So this can be further rewritten as x squared negative 1 times y3 positive 3 times x y2. I can take y1 out. If I were to do that, it's going to be 1 negative m squared times y1 is equal to 0. Now let us check with the original system what we were given. So you can see that clearly. X squared negative 1 times y3, x squared negative 1 times y3, so that check is fine, and we will have to go and check for the other quantity. So let me do that. So the other quantity is 3 times x y2, 3 times x y2, and 3 times x y2, check, and finally you got 1 negative m squared times y1, 1 negative m squared times y1. So hence we can state hence proved. This is a beautiful result, students. Thank you so much. We'll meet in the next class with a different topic.